give a quick overview of assignment 7. I've already cloned the repository here. Go ahead and take a look at the README and Markdown preview. We'll discuss exactly what the details of what you have to do here with implementing these functions. But before we do that, first I want to go over a quick discussion of the Julia REPL. So the Julia REPL, that's REPL, that stands, it's an acronym for Run, Evaluate, Print, Loop. And we can enter that by just typing Julia on the command line. And in Python, you might call this a console. MATLAB has something similar, but in Julia, it's often referred to as the REPL. So this is a place where we can do interactive coding. Like for example, we could just say 2 plus 2. It's going to give us 4. We can call some math functions that are loaded in the standard library. We can access old commands with the up and down arrows. We can store variables. So I'm going to assign x equal to 7, and we can recall it later. We can also use that, of course, in other code or functions. So in this case, I'll just create some little function or a little code that interpolates the value of x into the string x equals. So there we have that. There's a macro that does something similar in Julia called show. So if you call the macro show on x, there's a lot of other macros available. For example, there's one time that evaluates the time it takes to run a function or run a piece of code. I'll let you refer to the Julia documentation for discussion of all the other macros. We can enter a help session by using the question mark, and you see the prompt there changes to help, and then we can just type in a keyword search. So for example, sign. It'll bring up the documentation for the function sign. We can, there's also a package manager built into Julia. And so in this case, the repository we're in is actually a small package in and of itself. And I can tell that because it has a project.toml here. And if you want to open up, look at that, we can see what it is. So it defines the minimum compatibility for Julia. And it also defines some extra packages that are installed. And in this case, it's only this package test. However, we can enter the package manager in Julia by using the left-facing square bracket. Hit that key and you see again the prompt changes. Now a couple things here. First of all, you see that there's a v1.7. That means that the environment we are in this REPL is the main environment of Julia. But what we actually want to be to interact with this package, the assignment7 package here, as defined with that project toml, is to be in that environment. So an environment is a sandboxed place where only the packages that are defined within that environment or defined within that project toml will be available. So in this case, if we type activate dot, meaning to type here, then we can activate that environment, and you see that again the prompt has changed, and we're in the assignment 7 environment. So, for example, if we wanted to add a package like plots, for example, we could just say add plots, and this is going to take a little while. But once that finishes, we can reopen the project toml, and you see that there's now this additional dependency on plots that wasn't there before. So that tells us that now this plots is installed into our assignment 7 environment. Again, this is just a sandboxed environment where any other packages outside of those you explicitly list in the project toml or install here, only those will be available. Okay. The package manager is also where we would run tests. So this package has a test folder with some tests defined. Now, I expect them all to fail because there's no implementation here. But if we type test, this will go ahead and run the tests. And again, they're all going to fail because nothing has been implemented in this package so far. Okay, but this is where you could run tests from. So to get out of the package manager, we're going to hit Control C. You see our prompt returns to Julia there. Another thing we can do from the prompt here in the REPL is if we hit the semicolon, you see again the prompt changes to shell, and now we can actually run shell commands. So you know, we just want to echo something back, or type ls, of course, to list the directories. Again, we can type Control C to exit out of the shell. And then to exit out of Julia, we can type either exit, and exit is a function, so we have to type open close parentheses, or we can relaunch Julia. And this time, what I'm going to do when I relaunch it is I'm going to use the argument project equals dot, meaning, you know, here, this location. And what that'll do is it'll actually launch Julia with the environment already activated. So if we enter the package manager, you see that instead of v1.7, that it's already in the assignment7 environment here. So what I'm going to do is, while we're here, is just go ahead and remove that plots. We don't need it for this assignment. I'm going to hit Control C to get out of the package manager. And then the last thing I was just going to show you is that we can hit Control D to exit Julia instead of typing the exit function. So now that we discussed the REPL a little bit, I'm going to discuss this assignment a little more, right? So basically what we have here is in the source directory, there is a file assignment7.jl. We can take a look at that, and it has at least the beginnings of a few, you know, the names of a few functions defined, but they're not implemented in any way. And so basically the task at hand here is to implement the functions as described. And this is, you know, basically the purpose of this assignment is just to get used to using the REPL, running tests, and you know, just using different, implementing different function argument types. So it's a very simple assignment, just to kind of give you an opportunity to get used to these things. But basically what we'll want to do is for the function add positional arguments, we're going to want to add 3 arguments such that, and then have the function return the sum of those arguments. So I've defined the application programming interface here. So for example, if I give the arguments 1, 2, and 3, it should return 6. The third argument should have a default value of 2, right? So if I don't give a third argument, the value is automatically 2. So again, in this case, 1 plus 2 plus 2 is 5. So if I leave off or omit the third argument, then with 1 and 2 as the first 2 arguments, it should return 5. So the next thing I just want to demonstrate here in the second part is using that Unicode can be used to define functions and operators in Julia. So here's a little Sigma signal, and I guess I should show you how you might be able to create this from the REPL. We can, again, I'm going to enter the REPL, and what we can do is we can type, if you know the LaTeX command for Sigma, in this case it's slash Sigma, type like that, and then if we hit tab, you can see it automatically replaces our text with the Unicode symbol, right? So that's one way to create it. In this case, I'm just going to assign it to a variable, and then again, if we type slash capital SIGMA tab, then you see that we get it there. If we hit return, it'll return it to the screen, print the value. So I'm going to hit Control D to exit out of Julia again, return to the README. Basically on the second one, we're just going to use the Unicode symbol to basically replicate the function capabilities of add positional arguments. You'll have to add that yourself into the file. It's not there. You can add it yourself. And then the third one is going to be to implement some keyword arguments, right? So with keyword arguments, we have to explicitly say what the arguments are. we want the keywords to be A, B, and C, and they should have default values of 1, 2, and 3 respectively. So again, that's A equals 1, B equals 2, C equals 3. And so if we call the function like this, it will return 6. And again, because they all have default values, we can omit any of them, and they should take on their default values. So again, if we just leave A and B, if we call with the function with A and B defined but not C, C is automatically 3, and so it will return 6. Okay. The last thing we want to do is just get some practice implementing an anonymous function. And so this function, return anonymous function, will actually return a function, right? And so the return statement should be an anonymous function implementing the equation 1 plus x squared. And the way you would use this is you first have to call the function, return anonymous function. You can assign it to any variable. In this case, I just call it, assign it to f. And yes, a function can return a function. So f is now a function that I can call. For example, if I call it with 2, 2 squared is 4 plus 1, so that will give me 5. Or if I call it with 3, 3 squared is 9 plus 1 should give me 10, right? So that's how you would do that. Now, I already showed you how to run the test from the REPL, but you can also run the test from the command line directly by using this line of code here. So in this case, I'm just going to copy this and go back and paste it on the command line. So I'm not inside the Julia REPL here. I'm just running it from the command line. And again, nothing's implemented, so all the tests will fail, but this is how you can run it from the command line. So that give a little overview there of assignment 7.